Fronius. Hello and welcome everyone once again to our weekly Fronius webinar. Today we shall be discussing the topic energy storage with Fronius. So we will be basically looking at the different ways we can use Fronius products in order to achieve energy storage. And as usual, to do this with me today is my colleague, David Mwangi. He is the technical sales advisor for Eastern Africa region. He is based in Nairobi, Kenya. And then, of course, myself, Cyprian Okolo, who is the technical sales advisor for the Western Africa region. I am based in Lagos, Nigeria. So let's have a look at the agenda for today. We shall start off with looking at the entire Fronius inverter range, and then take a brief look at the various solutions that are provided for maximum independence. We'll have an overview of these solutions, then check out battery compatibility, and then take some time to look at specific Fronius energy storage solutions, which includes the Fronius Home Pilot, the Fronius WAP Pilot, and then, of course, at this point, I'll be handing over to David Mwangi, who will now take us through further details about the Fronius GEN24 Plus inverter, the BYD Premium HV battery. We'll take a look at AC coupling, and where we'll be having a brief look at the microgrid solution, and then now have a look at how this applies and how they can be viewed in Fronius Solar.web. Afterwards, we'll be giving you further information. Great. So without further ado, let's now continue with the presentation. So first off, as seen or shown in the agenda, we shall be looking at inverter ranges. So to start off with the Fronius Sunrise that was first manufactured in 1995. This is actually our first brand of inverters that were manufactured. And as you can see, as it rises in chronological order up to the Fronius Tauro that was rolled out in 2021. Yeah, so the good thing about this is that we're proud to say that some of the inverters, some of the Sunrise inverters manufactured in 1995 are still in service up till today. Great. So I'm getting feedback that the audio is not too good. So please, I want to be sure if it's an isolated case or if it cuts across. So please, if you can hear me clearly, please, I would love to see a hand raise. You could just click on the hand button so that I can be sure that you can all hear me loud and clear. Thank you very much. Okay, so thanks a lot for the positive feedback. So for those complaining of the sound audio quality, please, maybe you'd have to check your side of your system connected. Great, thanks a lot for the positive feedback. We shall now continue with the presentation. So as earlier said, the Sunrise, which was manufactured in 1995, is still in service up till today. And the owners of this system enjoy the services of our tech support personnel up till this day. So it means that whatever Fronius product you have, be it the Sunrise, be it the IG series that were manufactured afterwards, or the Snap inverters, or of course our new flagship products, that is the GEN24 Plus hybrid inverter, or the Tauro, you can be sure of getting the best tech support from our experienced tech support personnel. So going forward, we shall be narrowing down to the inverters that we have in play that can be used to achieve Fronius energy storage, of course. So starting off with our hybrid inverters, we have the Fronius Simo Hybrid. The Fronius Simo Hybrid comes in power class of 3, 4, and 5 kilowatts. Of course, Simo depicts that it is 3-phase. it is directly connectable with the battery, and of course, has a possibility of giving out or supplying three-phase backup power. But I must mention here that this particular inverter is not too popular in sub-Saharan Africa. But of course, we have a few installations, especially in South Africa. And of course, I must say here also that owners of this system, of course, not left behind. They also continue to enjoy the full support of our tech staff. So going forward, we have our latest hybrid product, which is the Fronius GEN24 Plus series inverters. So in particular, discussing first of all about the Primo, which is a single phase inverter. It ranges from the power classes 3 to 6.0 kilowatts, directly connectable to the battery, and then has the possibility of supplying single phase backup power, and then also has the PV point feature. We'll be talking about the PV point subsequently. And then, of course, we have the Fronius Simo GEN24 Plus. It ranges from 3 to 10 kilowatts. Simo, of course, depicts that it is three-phase, directly connectable to the battery with, of course, 2 MPPTs, same as the Primo. And then, of course, supplies three-phase backup power. Also equipped with the PV point feature. Good. Now let's go ahead to solutions for maximum independence. So we shall be taking a view of how these inverters are implemented to give us maximum independence or autarky. Now, we'll first view for the Simo, the GEN24 Plus Simo and Primo. As earlier stated or shown in the previous slide, we have the single phase and the three-phase variant. Single phase stretching from 3 to 6, and the Simo stretching also from 3 to 10 kilowatts. This is, of course, a previous snippet, but then there was an addition to the portfolio for the Simo GEN24 Plus. So it now includes power classes of as low as 3 kilowatts. Major difference between the Simo and the Primo GEN24 Plus, of course, apart from their power handling variation, is the maximum DC input voltage. For the Primos, the maximum DC input voltage is 600 and the minimum is 65 volts. But then for the Simo, it's 80 volts minimum and 1000 volts maximum, as can be seen. And I must state here that we have won several awards, starting from the very first day, year that it was manufactured, even up till this day. Going forward to the Fronius Simo hybrid, just as stated earlier, it comes in a 3, 4, and 5 kilowatt range. Has IP protection of 65. And then, of course, it has a possibility for Superflex design and a dynamic peak manager. So as earlier said, not too common in sub-Saharan Africa, but then all owners of such systems can rest easy because we are here to fully back them up. Good. Now going down to particular solutions or Fronius products used to attain storage solutions. We have the Fronius Home Pilot. So basically, the Fronius Home Pilot is a device manufactured by Fronius, of course, that allows a homeowner to heat water with excess solar energy and, of course, to be used immediately or later on in the day or probably in the night. We shall be saying or giving you more information on this in the subsequent slide. Good. Talking about elements that are basically used, Fronius products that are used to achieve maximum independence or to ensure the success of our Fronius storage solutions. We have the smart meter, the Fronius smart meter, of course. So we have them in single phase variant for residential, single phase, 3-phase for residential, and of course 3-phase commercial use. For the single phase residential, it comes with an ampacity of 100 amps. For the three-phase variant, it comes with an ampacity of 65 amps per phase. And then for the commercial variant, the smart meter comes with current ampacity of as high as 5 kiloamps. This definitely means that we'd have to make use of current transformers to be able to bring down this high current value to user-friendly levels, usually 1 amp or 5 amps secondary current. Good. Let's now have an overview of the various solutions provided by Fronius. So it's going to be divided basically into 3 parts. So we're going to go through the first part that has to do basically with DC coupled battery storage systems. So here for the storage solutions, we have battery storage solutions, thermal storage solution. So, and we have the various setup to provide the various storage solutions that they come with. So to start off, we have this here, the Fronius GEN24 Plus inverter with, of course, the storage element, and then, of course, the smart meter and the Fronius Home Pilot. So with this setup, we can achieve battery storage solutions. Of course, the GEN24 Plus in hybrid inverter, as you would be informed later by David Mwangi, is compatible with the BYD battery box premium, HVS and HVM. So with this, you can achieve a battery storage solution. You can also achieve thermal storage solution, and of course, grid backup function. The degree of self-sufficiency for this particular solution is very high. So we're talking about up to 98 to 90, yes, between the range of 98 to 99% of degree of self-sufficiency. It can be as high as that, actually, which is a very, very good value. So going forward, we have the setup, in this case, with the use of the Fronius SIMO hybrid inverter. So that's just the difference between it and this the previously discussed solution. So with this, we can also achieve battery storage solution with the BYD battery box HV and the BYD battery box premium HVM. We can, of course, also have thermal storage solution and grid backup function. Also, it has a high degree of self-sufficiency. With the same Fronius SIMO hybrid, we can, of course, it is also compatible with the LG Chem Resu battery. With this, we can achieve a thermal storage solution, and of course, a battery storage solution with the LG Chem Resu, but not grid backup function. Of course, as stated here, the degree of self-sufficiency is also very high. So taking another look at another variant of storage solution, in this case, with the exception of the Home Pilot. So with this, obviously, we can see that we cannot have a thermal storage solution with this particular setup. That is with the GEN24 Plus hybrid inverter and the SIMO hybrid inverter. We can only achieve or get battery storage solution with their respective compatible batteries, as here stated, and grid backup function, with, of course, the exception of the LG Chem Resu. Good. Looking at the second part of the Fronius storage solution variants, we have a unique Fronius storage setup here. So this has to do with PV string coupled battery storage system. We'll have a closer look at it subsequently. So with this, you can achieve a battery storage solution. As we can see, there is no Home Pilot, so we cannot have a thermal storage solution, and there is no grid backup function. For this setup, the degree of self-sufficiency is high. So next up is the AC coupled battery storage system. So it either can be achieved either with the use of the hybrid inverter, the GEN24 Plus inverter, with, of course, the battery storage element or the snap inverter with the battery storage element. So with this, you can achieve battery storage solution, and then grid backup function is also possible under certain conditions. And of course, we are going to discuss this condition subsequently in the next slides. Yeah, the degree of self-sufficiency for this case is high. And then next up, we have, in this case, the addition of home pilot, and with the exception of storage elements. So with this, we can achieve thermal storage, but without battery storage. So yeah, grid backup function can be achieved under certain conditions, but then in this case, because of the unavailability of battery storage system, the degree of self-sufficiency in this case is medium. And then lastly, we have a storage system ready with hybrid inverters. So in this case, one unique feature, especially with the Fronius GEN24 Plus hybrid inverter, is that you can actually get grid backup function under certain conditions, of course. So this means that even without storage elements and even without the home pilot, you can actually get a backup function from this particular inverter. But then the degree of self-sufficiency is low. We shall be giving you further details in this regard. Now let's take a look at battery compatibility. So for a DC coupled storage system, this is basically how it looks like. So first off, we have a system connected to the PV generator, that is the Fronius inverter, and then of course communicates to the Fronius smart meter via the Modbus RTU, which smart meter now connected to the utility smart meter and of course to the grid. So of course this setup is basically makes it possible to feed back into the grid for cases where feeding is permitted. Of course, with this, you can successfully render power to your household load, and then, of course, store energy to your DC coupled storage system. And then there's a unique case here, because for this case, it is possible to have power supplied to what we call the opportunity power, or PV point, as it is fondly called. Yeah, so in this case, it means that even without grid supply, or even with the absence of battery, you can of course have up to 3 kilowatts of power supplied to any load connected to this PV point. That's basically what this means. So going forward, to look at the battery compatibility, we see here clearly that the SIMO hybrid is compatible with the BYD battery box HV. So HV 6.4 kilowatt hour to 11.5 kilowatt hour, and also with the BYD battery box premium HVM. So 8.3 straight down to 22.1. And also compatible with the LG Chem Resu 7H and 10H. So for the Primo GEN24 Plus, it is only compatible with the HVS and the HVM, as earlier said. Now for the HVS, it is only compatible with the 5.1 and 7.7 module variant, and then the 11.0 to 19.3 module variants. That of the SIMO GEN24 Plus is compatible with the HVS and HVM also. For the HVS, it's compatible with the battery range 5.1 to 10.2, and then HVM 11.0 up to 22.1 kilowatt hour respectively. And I must note here that it is also possible to parallel the 19.3 kilowatt hour battery tower up to 3 times. And then once this is done, you can have a battery storage capacity of up to 57.9 or approximately 58 kilowatt hour. Good. So going forward, just like I promised, to explain further what the PV string coupled system means. So PV string coupled system is a kind of a unique setup that has the PV generator connected to a stringed coupled storage system. So what this does is from this PV connectable strings storage system, it's now supplies power or DC to the inverter for onward conversion to AC, and then this now, of course, supplies the load. So what this does is to, as we usually have, or contrary to what we usually have, we have the storage module coming before the inverter. So this, of course, stores energy directly generated from the PV generator or the module, PV modules, and then supplies power to the load directly from, of course, via the inverter. And then the power drawn from this storage element is actually dependent on what is demanded from at the load point. Of course, connected to the Solar.web AC sensor, which is further connected to the Fronius smart meter. Would have further look on this. As you can see that this product, that is Solar.web, comes in different variants that are compatible with these respective Fronius inverters, including the Fronius Primo, Galvo, and Simo. The Galvo has been discontinued, but then, of course, for all those having the system, of course, you can as well make use of it with the respective variant of the Solar.web. So, yeah, like I earlier said, this product, the Solar.web, comes as a strand coupled storage system. It comes in different capacity levels. Storage sizes ranges from 2.4 kilowatt hours up to 12 kilowatt hours. And then, of course, you have them scalable up to 60 kilowatt hour for large systems. With the configuration and how it is connected, it is basically suitable for storage solutions in the single phase market. Great. Now let's have a look at the Home Pilot. So for the Home Pilot, as earlier stated, this is a device, a device that can be used to direct surplus power to heating elements, or basically ohmic loads. So it is efficient. It brings about efficient usage of surplus energy, of course, for the optimization of self-consumption. In terms of application, it can be connected, or it can, of course, activate a heating rod for hot water generation. So, of course, you have heating rods connected inside a water storage tank. So this Fronius Home Pilot now triggers it so that it can now heat up the water in it for generation of hot water. It can also be connected in such a way as to provide for heating of infrared elements. It can also serve as a source of heat for towel heaters. And of course, just like I said earlier, it is applicable once the load are all purely resistive loads. So if you have any reactive load, or let's say inductive or capacitive load, this will not work. So it only works with purely resistive load and can supply up to 9 kilowatts of output power. So looking at various applications of ohmic heating systems, it can be applied for electric underfloor heating, as can be seen, for infrared panels, and of course, as earlier mentioned, heating rod in a water storage container, or boiler, as you preferably call. So just to describe how this can be applied in terms of hot water generation with the Fronius Home Pilot, let's say we have a system with a PV generation of 1,500 watts or 1.5 kilowatts. Without the Fronius Home Pilot, what happens here is that in the case where the load draws just 1 kilowatt or 1,000 watts, it means that 500 watts will now be directed to feed in to the grid. but that's for situations where grid feeding is allowed. In most cases in sub-Saharan Africa, this of course is not allowed. So what this means is that 500 watts is going to be wasted in this scenario per se. Wasted in terms that for this particular situation, the Fronius inverter will of course throttle down and only supply the load with the exact amount of power that it needs. So let's say in a case where we now want to explore the use of the home pilot to further increase our self-sufficiency, we would now have a home pilot connected to this system. So what it does in this case with the same scenario is that once the nominal loads have taken the power demanded, the 500 watts will now be channeled, the surplus 500 watts will now be channeled via the home pilot to now trigger the heating element, in this case the heating rod, that now heats up the water, say cold water, in the storage tank. And then of course this now provides hot water for use either immediately or subsequently. This is also connectable with temperature sensor, PT1000 variant of temperature sensor for enabling proper monitoring of this storage solution. Good. Now let's now go to another say variant of storage solution provided by Fronius. Yes, we want to suitably call it, in this case, mobility storage solution with the Fronius Watt Pilot. Mobility storage solution basically meaning that with the Fronius Watt Pilot, we can, of course, store energy in the car battery for later usage. So with this, it comes in handy and makes it possible to, apply various means of, solving the surplus energy question, basically how to make use of our surplus energy generated. Yeah, so in this case, we can make use of the surplus energy to charge our car batteries for later use. So this Fronius Home Pilot is what we call Fronius's EV charging solution. It's used to smartly store energy for mobility usage. So we have the mobile and stationary variants, up to 7.3 kilowatts for single phase and 22 kilowatts charging capacity for the three-phase. And another unique thing about it is that it is possible to automatically switch from single-phase charging to three-phase charging. Giving you further more information about the Watt Pilot, like I said earlier, we have the mobile version, which is a carry-on version, as you can see, coming in the 11 kilowatts and 22 kilowatts variant. We also have the stationary version, which is the Watt Pilot Home, that comes in the 11 kilowatt variant. So it is also adaptable to Fronius. We have an app already, and that is adaptable, which makes it easy for monitoring, and then making it, of course, easy to program whichever charging function that we want the Watt Pilot to perform for us. Yeah, so now let's look at basic function of the Watt Pilot. Just like the case of the Home Pilot, what it does is basically to monitor the system, of course, in communication with the data manager inside the inverter, of course, to smartly redirect surplus power to charge the vehicle, your EV. It could be a car, it could be a motorbike, it could also, of course, be a tricycle, whatever the EV is. So this is basically how it works, just similar to what we have in the case of the Home Pilot. So we, of course, achieve this by using either the Snap inverter or the Fronius hybrid inverter. Another unique thing about the Watt Pilot is that it makes it possible for the integration of other energy sources. So we could have a wind turbine, a small hydropower plant, or even an older version of the Fronius inverter, or even if it's not a Fronius inverter, it is actually possible with the usage of the Fronius Data Manager box and the smart meter to achieve this. Yeah, so as earlier said, you can have it connected supplied with various external sources. So it could be PV source, windmill source, or even a small hydro power source. Main thing is with the sensing the availability of surplus power, it now redirects this surplus power and then uses it effectively to charge the EV for later use. With this, I've come to the end of my part of the presentation. I will now be handing over to David Wangi, who will be taking us on the next part of the presentation. So, David, you can continue from here.
All right. Thank you very much, Cyprian, for the first part of the presentation. I'll now be going through in more details the Fronius GEN24 Plus and look at the various capabilities of this hybrid inverter. So number one, I think for all those probably who have heard about the GEN24 before, is the fact that this is an inverter that is uniquely versatile, and this is enabled by quite a number of things. Already discussed by Cyprian is the fact that this inverter is available in two key variations, the single-phase version as well as a three-phase version, so up to 10 kilowatts. So both the inverters, of course, whether single-phase or three-phase, will have 2 MPPT inputs and one battery input. So that makes it possible for energy storage in a battery system. Then in terms of using the GEN24 for a green energy future, because this is something that is very dear to Fronius, we want to see an individual energy transition. We want to see expansion possibilities, whether you are storing your energy electrically for later use or in hot water systems. These are all possibilities for green energy that will be facilitated by the Fronius GEN24 Plus. Of course, the main goal for this kind of a solution in the end is for you, the end user, or the end user, so to speak, is reduced energy costs. So that's why we are actually discussing this webinar today. So we can also look at this green energy future being possible because the GEN24 is a very high quality product. So like already mentioned by Cyprian, we have won quite a number of awards that have been tested or carried out by third-party organizations regarding how the GEN24 works, especially with the lithium iron phosphate batteries from BYD. So that can guarantee you a lot of success for this green energy for the future. In terms of energy management, the GEN24 Plus will also play a very big role to effectively and efficiently manage the energy that you are generating. This means that with only a Fronius smart meter, you can achieve both load management as well as a load profile analysis to see exactly what is going on. And the end goal of this energy flow management is to maximize on your self-consumption. So this maximizing self-consumption, of course, would come in together, especially when you are doing energy storage, whether be it hot water generation in an EV or in a battery system for backup applications and so on. In terms of maximizing your self-consumption with the GEN24 Plus, this is where the GEN24 Plus is going to differentiate itself from other, let's say, similar inverters in the market. So with the availability and the compatibility of the GEN24 and the OnPilot, you are able to generate your hot water directly. That's already discussed by Cyprian. Also using surplus energy, you can have efficient energy storage through a battery system. So through the various configurations that are possible with the GEN24 Plus, you can decide that depending on the threshold of surplus energy available, that you give priority number 1 to the OnPilot all priority number 2 to energy storage in a battery system. So this is possible within the GEN24 settings. Also, something that is very, very interesting with the GEN24 Plus, already briefly mentioned, is the fact that you can use the GEN24 with or without a battery system. In most cases, especially when you look at off-grid inverters, you almost always require a battery for the inverter to start. However, the GEN24 differentiates itself from this kind of requirement because with only a PV connection, the GEN24 is able to start generating power. So, and then you can do very easily retrofitting of the battery system at a later point, depending probably when you were doing the installation to start with, maybe the customer was not prepared budget-wise, and therefore at a later stage, maybe the company has the customer has the budget to install the battery, and therefore this can be very easily retrofitted into the GEN24 system. Therefore, this retrofitting makes it possible to increase your self-sufficiency, and in a battery connection with GEN24 SIMO 10, you can get up to 9 kilowatts of power coming from the battery system. Other things that are unique to the GEN24 Plus and also available within the Fronius inverter portfolio is the fact that we have the dynamic peak manager, and therefore for residential use or light commercial use, you don't have to worry too much about maybe partial shading of your PV system, because this is directly addressed by the dynamic peak manager within the GEN24. So this would ensure that you have low losses despite of the partial shading conditions, and this is effected or made possible by the examination of the entire IV curve of the modules of the PV array by the GEN24 algorithm, that is the dynamic peak manager. So this makes it possible to use the GEN24s and also other Fronius inverters without the need for DC optimizers connected to your PV system. In addition, also something that is very, very unique with all Fronius inverters is the fact that we employ active cooling technology. So this is not different in the GEN24 Plus. The only difference is that with other Fronius inverters, you in most cases will have the cooling fans on the sides of the inverter, and then you have some slots at the top of the inverter where the hot air is escaping from the inverter. But with the GEN24, you have a centrally located fan, air cooling fan, and this makes it possible to achieve a very long lifespan of the inverter compared to inverters that are passively cooled. Because what is the basic rule of that is that for every 10 degrees increase in the operating temperature of any electronic part, then you basically cut the life of that part by half. So in most cases, for electronics to be able to protect themselves from damage, what they do is to derate power beyond a certain operating temperature. But when the inverter is actively cooled, then you can be guaranteed of even more yield, regardless or notwithstanding the high ambient temperatures. So let's now look at the GEN24 Plus storage solution, and this we are going to look in conjunction with the BYD Battery Box Premium, HVS, and HVM. So of course, as you know, the BYD battery boxes are manufactured from lithium iron phosphate, which is very, very secure and does not have the thermal runaway characteristics that become eventually very dangerous for lithium ion batteries. So the BYD batteries in this regard are very, very secure. These batteries are also modular in the sense that for the HVS series, you can modularly expand the battery from 5.1 to 10.2 kilowatt hours in modules of 2 to a maximum of 4 modules. So that would form one battery stack like this. And then in the HVM series, you can expand modularly from 11 kilowatt hours up to 22.1 kilowatt hours. And this would be modules starting from 4 to a maximum of 8 modules that would form, therefore, the battery stack. As already mentioned, it's very easy to retrofit these batteries. So you could start like with 4 modules, and then later on you can very easily stack depending on which series you're using. If you're using the HVS, then the module stacks are starting from 2.6 kilowatt hours, and for the HVM, then you can upgrade in steps of 2.8 kilowatt hours to a maximum of 4 for the HVS and a maximum of 8 modules for the HVM. Of course, in terms of installation, this becomes very, very easy because you can do a ground mount system. So you just require a base of the battery stack, as we can see here. And then the commissioning process is very simple and straightforward. As you can see in this battery stack, there are no cables that are visible because the clipping mechanism allows the communication or power flow from one module to the next. And then at the very top, you have what we refer to as the battery management system that is connected to the Fronius inverter, even for communication via the Modbus RCU. So you can do quite a number of things when you have especially the grid available. So you can charge your battery also in backup mode. So, and this basically shows us how power flow is happening within the Gen24 setup. So we have the concept that we refer to at Fronius as the multi-flow concept, and this is fully integrated in the Gen24 as well. So you can have power flowing from your PV array to the battery system, and at the same time or simultaneously, if the PV array is not sufficient, you could also be drawing some power from your battery system and feeding the loads at the same time. So, and then during the night time, if you have a favorable grid tariff, then you can decide to pack some power back into the battery system if it was already used, and up to a certain limit, and then allow for charging the next day using the PV system. You can also using the Gen24, and this is where also the retrofitting becomes very, very simple. If you have an existing installation, you can have either a snap inverter that was there and exclude the PV array connected to a Gen24 system, although you can still have the snap inverter and a Gen24 in the same setup. Have the Gen24 connected to its own array, but this is not mandatory because the alternative then would be to connect the Gen24 and the existing snap inverter or other Fronius inverter in the setup through an AC coupled kind of configuration. And this would allow the power flow that is coming from the PV array through the snap inverter, for instance, the AC out then would be coupled to the Gen24 that would allow the charging of the batteries. So, and in this setup, then you can also get backup when the grid fails. Because as you know, in this kind of operation, if the grid fails here, in this case, then the snap inverter must also stop by default because of the grid code requirements. So just a repeat of the multi-flow technology, just to clarify how this is working. So you can have as a first priority, because when you install a PV system, the first priority are the appliances that need to be powered up. So this is the automatic power flow from the PV array through the Gen24 Plus system into your appliances. If you're allowed to export power, then you can feed the excess that is not going to your appliances to the grid. But in most cases, you are not allowed to feed power to the grid in the African market. So what that means is that you would require a Fronius smart meter, and then the Fronius smart meter would communicate with the Fronius Gen24 and would tell the Gen24 that this is the amount of, this is the rate of consumption at this point, and therefore all the excess energy can flow directly to the battery system for charging. As I mentioned before, then the advantage that you get with the battery system is that if the PV array is not generating enough power to cover what the appliances require at this moment, then you can have multi-flow of power from the PV array as well as from the battery system, and these are summed up together or fed together simultaneously to the load or the appliances that are operating at this point. So this would, with a battery system, prevent or allow you not to consume expensive grid power, and therefore, as I said before, increasing significantly your self-consumption rate. In addition to that, let's say you also have come into a situation whereby you have used quite a bit of your power from the battery system. The grid is still available, as I mentioned before, and you want to use the favorable grid tariff to charge your battery. So this is also something that can happen within the GEN24 configuration. And therefore, the setting that is activated within the GEN24 is to allow charging from the grid, and therefore you can activate that function. Also, if there is an existing installation, you can very easily AC couple the GEN24 to an existing PV installation with a Fronius inverter, as I had already indicated before. So therefore, with or without a connection of PV power to the GEN24, you have the possibility of battery storage integration to your PV installation. So this could be very useful for example, for light commercial application or homes, whereby, as I mentioned before, if the grid fails, then the primary inverter, which is purely grid tied, will also stop by default, and therefore all essential loads in a commercial setup that is not too big, maybe to a maximum of 10 kilowatts, can be directly fed from the GEN24 as backup. As already mentioned, the GEN24 also has a very unique feature that we refer to as the PV point, and this would give you inexpensive backup power. So this does not require that you purchase a battery system, and this would guarantee you even more energy independence. So this is a basic backup power connection and is integrated as standard in all GEN24 Plus inverters, whether single phase, which is the Primo, or the SIMO inverters. So the PV point has just a few requirements and things that you should note about the PV point. This will only be supplied in the event there is a grid failure. And then, of course, if the grid comes back, there is an automatic reconnection. As already mentioned by Cyprian, you can power to a maximum of 3 kilowatts in single phase only. So it doesn't matter whether the GEN24 that you're using is 3-phase. The PV point can only provide maximum 3 kilowatts single phase power and can surge for a few seconds to a maximum of 4.1 kilowatts. That would make it quite easy to start inductive loads if you have them as essential in the essential loads circuit. In terms of installation of the PV point, you do not require any additional accessories, so to speak. The only thing that you require are safety devices, maybe an RCD that is connected to the socket that is feeding the essential loads. But uniquely also, you cannot get 3-phase backup power from the GEN24 Plus. So this is, I think, one of the only very few inverters that you can find in the market that can provide you with 3-phase backup power. And this therefore means that you can supply, as opposed to the PV point that is giving you a maximum of 3 kilowatts, you can supply your entire household with backup power in the case of power failure from the grid. And what is also important to note here is that because the GEN24 is still grid connect inverter, you will have a bit of a lag when there's a power failure of about 60 seconds or so before you get the backup power connection. And then, of course, when the grid comes back, you are going to have an automatic reconnection. So, as I said before, with the battery system, even in backup mode, you can still have parallel charging or discharging of the battery system. So this makes it very flexible for the battery. Regarding the backup connection, you are going to require a few accessories that can be covered, I think, in a separate training for the GEN24 Plus and how to commission that. Let's now have a quick look at the BYD battery box premium, HVS and HVM, because this is the only battery series from BYD that are confirmed or tested for compatibility with the GEN24 Plus inverters. So you have the flexibility to use these two versions that offer higher capacity. And then you also looking at a compact design. So in terms of the installation, it's going to look very, very neat. The BYD battery box will offer you feedback in terms of the operating status of the battery via LEDs. But also this can be monitored, especially as far as the state of charge is concerned, as we are going to see later directly in Fronius Solar.web. This BYD battery box will also offer you ease of installation. So you require just, in terms of module, very few due to the doubled capacity per module. And then the improved mechanism for locking between the modules makes it very easy to install. You can also install in parallel up to 3 storage towers without any additional components required. And therefore, if you're using the HVM, which is going up to 22.1 kilowatt hours, then you can parallel 3 of these towers to make up to 66.3 kilowatt hours, which already makes it very good backup and self-consumption system for a light commercial application. So just to go through the key details regarding the HVS and the HVM, all this has been touched on before. The only thing that we can mention here is in terms of the operating and the starting voltages for these modules. As we can see, the HVS has a module voltage starting from 102.4, and therefore that's why we have a limit of up to 4 modules, because we do not want to exceed 409 volts when connecting to the Fronius GEN24 Plus inverters. So when it comes to the HVM series, we are starting with a module voltage of about 51.2 volts. And therefore, in this case, we can go up to 8 modules stacked together. And this will also be just about 409 volts. In terms of nominal voltages, you can see that with only 2 modules of the HVS, you can already start producing power from the GEN24 Plus inverters. And with the BYD HVM, with about 4 modules, this is what would be recommended to have a nominal voltage of 204 volts. But ideally, you want to come to nearly 409 volts to increase your efficiency overall of the system. So the combination now between the various Fronius hybrid inverters with the BYD batteries, my colleague Cyprian already talked about the Simo hybrid inverter, which is available in the power classes 3 to 5 kilowatt AC output. And this inverter can be combined with the BYD battery box HV, which is from 6.4 kilowatt hours up to 11.5 kilowatt hours, and also the BYD battery box premium HVM, which starts from 8.3 to 22.1 kilowatt hours. When it comes to the GEN24 Plus inverters, so whether the Simo or the Primo series or the GEN24 Plus, you can then use the BYD battery boxes HVM and HVS. What is unique about the GEN24 Plus, as I had already mentioned regarding the various testings that have been done. For instance, one of the tests that was done that came back with very good system performance index figures was done by the HDW in Berlin in 2020. And this was a battery inspection test that had quite a number of other inverters that were already also tested at the same time. So the highest efficiency was achieved only using the Fronius and the BYD battery system. So you can see the inverter efficiency from Fronius GEN24 Plus is around 9.73, and the system performance index for a 10 kilowatt peak system that was considered came back to around 94%. So as you can see, the Fronius GEN24 Plus using the BYD battery box H 11.5 kilowatt hours returned the highest efficiency. And if you look at the scale down here, we can see that the efficiency class that was achieved by the GEN24 Plus with the BYD battery box was class A. So it was only one of the 2 inverters that achieved class A efficiency. So most of the other off-grid inverters would actually not even hit 90% system performance index. So this is actually something that is very, very unique for the GEN24 and the BYD battery system. For more on this test, kindly, once the webinar material or recording is shared, you can read it further on this test and the criteria that was used via this link that is provided here. Let's now look at another possibility for energy storage, that is the AC coupling for microgrid solutions. The advantage of the AC coupling is the fact that, of course, it gives you a lot of flexibility of different batteries to use. It's not so limited as with the GEN24 and the SIMO hybrid inverters. So the concept, of course, of AC coupling comes from a DC coupled system, as you can see it here. So you have your PV array that is connected to a charging system, could be an MPPT or PWM charger that is charging directly to the battery, so DC coupling here. Then the battery system is feeding the DC power to the inverter, which onwards feeds your load. So in the DC coupled area here, the efficiency is very, very good. But when it comes to the conversion from DC to AC by the off-grid inverter, then you have a bit of a loss in terms of the overall system performance. So therefore, to improve this kind of scenario, we have the possibility to AC couple a Fronius inverter and our inverter charger. There are quite a number of them that have compatibility with Fronius inverters. And then you can directly charge your system through this back-feeding AC power to the inverter charger, then back to the battery. As I mentioned, this gives you a lot of flexibility because then you can use either a 12, 24, or 48-volt battery system. It doesn't matter whether it's lithium iron phosphate or you want to go for the cheaper lead acid batteries. So there is a lot of flexibility there. But to make the system even more secure, because if you have this setup only and the batteries run out at night and you do not have either the grid or a backup generator, you could have problems of the inverter charger starting, and therefore the reference voltage and frequency for the Fronius inverter is lost. To make it safer, then we do recommend that if you do AC coupling, part of the PV array is directly DC coupled to the battery through an MPPT charger. Then you have the normal AC coupling that is done through the AC bus bar of the inverter charger to the Fronius inverter, and therefore this guarantees a very safe system operation. Just for the sake of those who are not very familiar with the AC coupled concept, it operates in this manner. So you have to the left here a diagram showing a situation whereby you have a lot of sunshine, and therefore generation by the PV inverter is also very high. And the load consumption is not as much, as you can see by this corresponding arrow here. So most of the power or the energy that is available is going back to the battery system through the inverter's charger. If, on the other hand, we have a bit of a cloud cover or the irradiation levels are not very good, then the Fronius inverter is producing still whatever amount of energy it can from the DC source. And then the battery system is now supplementing whatever is coming from the Fronius inverter, and then the combination of the two is fed to the loads. But what happens in the case that you have a very bright day, the battery is nearly fully charged, and the Fronius inverter is still producing a lot of power? So this needs to be checked. So what would happen is that you need to have a mechanism to tell the Fronius inverter that the battery is fully charged, and therefore you only need to produce an amount of power that is required by the load at that particular moment. And therefore, in this case, we do refer to this principle as frequency shifting. So when you do a detailed AC coupling webinar or training, we can go through that particular aspect in details. So let's now have a quick look at Fronius Solar.web that would allow you to have overall visualization of what is happening with your entire setup. So as you already know that Fronius offers you a platform where you can monitor all your systems. Then you are able to see, in most cases, a lot of people have done purely grid connected systems where you monitor the production levels and the consumption levels. In addition, if you have a battery storage or on pilot included into your system for additional energy storage through the battery or hot water, then you can see what is the average water temperature in the course of the day. So you have a temperature scale on this side, and you can also be able to tell what is the level of charge of the battery over the course of the day as well. In addition to that, you can also be able to tell directly from Solar.web monitoring data which portion of consumption was supplied directly by your loads. So therefore, Solar.web is going to allow you to do even more detailed analysis of your PV system when you have both battery storage or hot water storage using an on pilot. So for additional information on how to dimension your battery system, this can be achieved easily using the Fronius solar configurator that has been in use for quite a while now. So when you're doing the sizing of your PV system, especially to double check whether your PV string design is correct, there is a section within the Fronius solar configurator that allows you to also do a quick check on which battery size and compatibility depending on the inverter that you have selected. So, but in addition to that, you can also do sizing of the battery system using the Fronius solar creator that was recently launched. So this is a replacement of the Fronius solar configurator. So it's a lot more detailed and it has a lot more features in it in terms of how it allows you to visualize and appreciate how the system overall is going to look like. So feel free also to go through the Fronius solar creator as well as the configurator once we share the webinar materials. And that basically brings us to near the end of this webinar. But for more information on the different Fronius products, you can visit our website. There's a nice download section for installers. And also for, if you're interested to look at other webinars and learning materials that we have done before, you can get this through the YouTube channel. There's a Fronius YouTube channel. And then we also have within there the African playlist. And then also to further get in touch with us, depending on what your questions are for technical support issues, training, sales, as well as after sales support, you can get in touch using all these contact details provided here. And then directly to either Cyprian or myself, depending on if you're in Western Africa, then you contact Cyprian. And then in East Africa, please feel free to contact me. And we are going to be very happy to support you in any manner that you can. So that brings us to the end of our webinar session for today. And I do take this opportunity to thank you most sincerely for taking the time to be with us today. And we hope that you have enjoyed the webinar and have gotten a lot of useful materials. So until the next webinar, goodbye for now and enjoy the rest of your day.